National Electrical Code Article 404.8 requires lighting contactors to be mounted in a readily accessible location. Article 404.8b specifies that contactors shall be mounted in a horizontal or vertical position and not upside down. NFPA 70E Standard for Electrical Safety in the Workplace Section 120.3e requires that electrical equipment be installed in a manner that minimizes the risk of fire or electric shock and is accessible for maintenance. Annex D 120.3e clarifies that this includes providing sufficient headroom for servicing contactors and other electrical equipment. Beyond code requirements, consider several factors when determining the mounting height of a lighting contactor. Firstly, accessibility is paramount. Contactors should be mounted at a height that allows for safe and easy access for maintenance, troubleshooting, and replacement. Secondly, proper ventilation is essential. Contactors should be mounted in well-ventilated areas to prevent overheating and potential damage. Thirdly, visual inspection is important. Contactors should be visible for routine inspections to identify any potential issues. Additionally, local codes and standards may have additional requirements regarding the mounting height of lighting contactors. It is crucial to consult with local authorities to ensure compliance. The recommended mounting height for lighting contactors varies depending on the specific application and environment. However, a general guideline is to mount them at a height of 6 to 8 feet above the floor for easy accessibility and maintenance. Proper mounting height is important for safety, maintenance, and compliance. Ensuring that the contactor is accessible will make future maintenance and troubleshooting easier and safer. Over time, components within a contactor may need to be replaced. If the contactor is not easily accessible, this can increase the risk of injury to personnel. Mounting the contactor in a well-ventilated area will prevent overheating of the components inside, which ensures a long service life. Regular visual inspections can help you identify potential problems before they become major issues. This can include things such as loose connections, damaged wiring, or signs of overheating. Adhering to local codes and standards is not only a legal requirement, but it also helps to ensure the safety of electrical installations. Consulting with local authorities will help ensure that you are following all applicable regulations. While a general guideline of 6 to 8 feet is recommended, the specific mounting height may need to be adjusted based on the application and environment. In some cases, it may be necessary to mount the contactor higher or lower to accommodate specific needs. When selecting a mounting location, consider the surrounding environment such as temperature, humidity, and the presence of corrosive substances. Extreme temperatures can damage the components of a contactor. Humidity can cause corrosion and short circuits. Corrosive substances can damage the enclosure and internal components. Select a mounting location that minimizes exposure to these elements. Also, consider the physical accessibility of the mounting location. Ensure that there is enough space to safely work around the contactor. Avoid mounting the contactor in areas where it could be easily damaged or obstructed. Consider the weight and size of the contactor when selecting a mounting location. Ensure that the mounting surface is strong enough to support the weight of the contactor. Use appropriate mounting hardware to securely attach the contactor to the mounting surface. When installing a lighting contactor, it's important to follow the manufacturer's instructions and all applicable electrical codes and standards. This will ensure that the installation is safe and reliable. Always de-energize the circuit before working on a lighting contactor. Use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical hazards. Never work alone on electrical equipment. Have another person present in case of an emergency. If you are not qualified to work on electrical equipment, hire a licensed electrician. Firstly, always review the National Electrical Code, NFPA 70E, local codes, and manufacturer's instructions before beginning any work on a lighting contactor. Secondly, ensure that the lighting contactor is properly sized for the intended load. An undersized contactor can overheat and fail, while an oversized contactor is simply a waste of money. Thirdly, use properly sized conductors and connectors. The conductors should be sized to carry the full load current of the lighting circuit, and the connectors should be rated for the conductor size and type. Fourthly, make sure that all connections are clean and tight. Loose connections can cause arcing and overheating, which can lead to fire or equipment failure. Fifthly, protect the lighting contactor from moisture and dust. Moisture can cause corrosion and short circuits, while dust can clog the contacts and prevent them from closing properly. Sixthly, provide adequate ventilation for the lighting contactor. Overheating can shorten the life of the contactor and lead to premature failure. Seventhly, label the lighting contactor clearly. This will help prevent confusion and ensure that the correct contactor is de-energized when performing maintenance or repairs. Eighthly, perform regular inspections of the lighting contactor. Look for signs of wear, damage, or overheating. Replace the contactor if any problems are found. Ninthly, keep a record of all maintenance and repairs performed on the lighting contactor. This will help you track the performance of the contactor and identify any potential problems early on. Tenthly, when replacing a lighting contactor, use a replacement that is equivalent to or better than the original. Using a substandard replacement can compromise the safety and reliability of the lighting system. Consider that the 6 to 8 foot mounting height is a guideline only. The ideal height may vary depending on the specific application and environment. For example, in a warehouse where forklifts are used, it may be necessary to mount the contactor higher than 8 feet to prevent damage. In contrast, in a building with low ceilings, it may be necessary to mount the contactor lower than 6 feet to provide adequate headroom. When determining the mounting height of a lighting contactor, always consider the safety of personnel. The contactor should be mounted at a height that allows for safe and easy access for maintenance and repairs. It should also be mounted in a location where it is not likely to be damaged by moving equipment or other objects. Lighting contactors are typically used in commercial and industrial buildings to control lighting circuits. They are often used in conjunction with time clocks or other control devices to automatically turn lights on and off. Lighting contactors are available in a variety of sizes and configurations to meet the needs of different applications. They are typically rated for 20 amps, 30 amps, 40 amps, 60 amps, 80 amps, 100 amps, 200 amps, 300 amps, 400 amps, 600 amps, 800 amps, 1000 amps, 1200 amps or more. Lighting contactors are an important part of any lighting system. By following the recommendations in this guide, you can ensure that your lighting contactors are installed and maintained properly. The cost of a lighting contactor varies depending on the size, brand, and features. Small contactors for residential applications can cost as little as $20, while large contactors for industrial applications can cost several $100s. When choosing a lighting contactor, it is important to select one that is appropriately sized for the load it will be controlling. An undersized contactor can overheat and fail, while an oversized contactor is simply a waste of money. Also ensure that the contactor is rated for the voltage and current of the circuit. Contactors are typically rated for 120 volts, 208 volts, 240 volts, 277 volts, 480 volts, or 600 volts. If you are not sure what size or type of contactor you need, consult with a qualified electrician. There are several different types of lighting contactors available. Some of the most common types include mechanically held contactors, which use a mechanical latch to hold the contacts closed, and are often used in applications where it is important to maintain the lighting circuit even if power is lost. Electrically held contactors use an electromagnet to hold the contacts closed, and are generally less expensive than mechanically held contactors, but they require power to remain closed. Definite purpose contactors are designed for specific applications, such as controlling HVAC equipment or lighting circuits. When installing a lighting contactor, it is important to follow all applicable electrical codes and standards. This will ensure that the installation is safe and reliable. Also make sure the circuit is de-energized before working on a lighting contactor, and use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical hazards. Never work alone on electrical equipment, and have another person present in case of an emergency. If you are not qualified to work on electrical equipment, hire a licensed electrician. Regular maintenance of lighting contactors can help to ensure that they operate safely and reliably. Maintenance tasks may include inspecting the contacts for wear or damage, cleaning the contacts with a contact cleaner, tightening the connections, and lubricating the moving parts. Frequency of maintenance will depend on the application and environment in which the contactor is used. When inspecting contacts, look for signs of wear, such as pitting, burning, or corrosion. If the contacts are severely worn, they should be replaced. Also clean the contacts with a contact cleaner to remove any dirt, dust, or debris. Use a contact cleaner that is specifically designed for electrical contacts. Check all connections to make sure they are tight. Loose connections can cause arcing and overheating, which can lead to fire or equipment failure. Tighten any loose connections with a screwdriver or a wrench. Lubricate the moving parts of the contactor with a light oil or grease. This will help to prevent wear and tear and ensure that the contactor operates smoothly. If you are not comfortable performing maintenance on a lighting contactor, hire a qualified electrician. Proper grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. Ensure that the lighting contactor is properly grounded according to the National Electrical Code and local codes. The grounding conductor should be sized appropriately for the circuit and securely connected to the contactor and the grounding system. Regularly inspect the grounding connections to ensure that they are tight and free of corrosion. Surge protection can help to protect lighting contactors from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. Surge protective devices, SPDs, can be installed at the service entrance, at the panel board, or at the individual lighting contactor. SPD work by diverting the surge current to ground, protecting the contactor from overvoltage. Choose an SPD that is rated for the voltage and current of the circuit. Install the SPD according to the manufacturer's instructions. Regularly inspect the SPD to ensure that it is functioning properly. If the SPD has been damaged by a surge, it should be replaced. Consider using a control system to monitor and control the lighting contactors. A control system can provide valuable information about the performance of the contactors, such as the number of operating cycles, the operating temperature, and the voltage and current levels. This information can be used to identify potential problems early on and to optimize the performance of the lighting system. A control system can also be used to remotely control the lighting contactors, allowing you to turn lights on and off from a central location. This can be useful for energy management and security purposes. Many control systems also offer features such as scheduling, dimming, and occupancy sensing. When selecting a control system, choose one that is compatible with the lighting contactors and that meets your specific needs. Install the control system according to the manufacturer's instructions. Regularly maintain the control system to ensure that it is functioning properly. Energy efficiency is an important consideration in any lighting system. Lighting contactors can play a role in improving energy efficiency by allowing you to control the lights based on occupancy, time of day, or other factors. Consider using occupancy sensors to automatically turn lights off when a space is unoccupied. Use time clocks or programmable controllers to schedule the lights to turn on and off at specific times. Install dimming systems to reduce the light level when full brightness is not needed. Use energy-efficient lamps and ballasts. Regularly maintain the lighting system to ensure that it is operating efficiently. Consider upgrading to newer, more energy-efficient lighting technologies. Emergency lighting is an important safety feature in any building. Emergency lighting provides illumination in the event of a power outage, allowing people to safely evacuate the building. Lighting contactors can be used to control emergency lighting circuits. Ensure that the emergency lighting system is designed and installed according to the National Electrical Code and local codes. Test the emergency lighting system regularly to ensure that it is functioning properly. Provide backup power for the emergency lighting system in case of a power outage. Consider using self-testing emergency lighting fixtures. A lighting contactor is an electromechanical device used to switch a lighting circuit on or off. It is similar to a relay, but it is designed to handle higher currents. Lighting contactors are commonly used in commercial and industrial buildings to control large banks of lights. They can be controlled manually with a switch, or they can be controlled automatically with a timer or other control system. Lighting contactors typically consist of a coil, a set of contacts, and a frame. When the coil is energized, it creates a magnetic field that attracts the contacts, causing them to close. When the coil is de-energized, the magnetic field collapses and the contacts open. The contacts are typically made of a conductive material such as copper or silver. The frame provides a support for the coil and the contact. Lighting contactors are available in a variety of sizes and configurations. They are typically rated for a specific voltage and current. They are also rated for a specific number of poles. The number of poles indicates the number of circuits that the contactor can control. Single-pole contactors can control one circuit, while two-pole contactors can control two circuits, and so on. When selecting a lighting contactor, it is important to choose one that is appropriately sized for the load it will be controlling. An undersized contactor can overheat and fail, while an oversized contactor is simply a waste of money. The National Electrical Code contains specific requirements for the installation and wiring of lighting contactors. It is important to follow these requirements to ensure that the installation is safe and reliable. Article 404 covers switches, including lighting contactors. Article 404.8 specifically addresses accessibility. This section mandates that switches, including lighting contactors, be readily accessible. This means they should be located so that they can be reached without the need to climb over obstacles or use portable ladders. The intent is to allow for easy operation and maintenance. Consider the physical layout of the space when choosing a location for the lighting contactor. Ensure that there is enough space around the contactor to allow for safe and easy access for maintenance and repairs. Avoid mounting the contactor in areas where it could be easily damaged by moving equipment or other objects. The mounting location should also be clean and dry to prevent corrosion. Also, take into consideration the ambient temperature of the mounting location. Lighting contactors are designed to operate within a certain temperature range. If the ambient temperature is too high, the contactor may overheat and fail. Avoid mounting the contactor in areas where it will be exposed to direct sunlight or other sources of heat. A licensed electrician should always be consulted for any electrical work.